Good evening, class. Good evening, class. Good morning, class. Come, let's start. Semua dapat nota, Everybody got the notes? So, hari ni kita akan cuba buat semua, all of chapter 6. Kita akan buat sebanyak yang boleh lah. Whatever we cannot finish, I will have another class. Cikgu akan adakan kelas yang lain untuk apa yang kita tak boleh habis hari ni. Everybody got the notes, Tak ada masalah, I just enabled the group chat, You all can use the chat. Boleh pakai chat. Okay, as usual class, seperti biasa. In my class cikgu, sila tanya soalan. Please ask questions. Don't be shy to ask questions. Okay, jangan segan untuk tanya soalan. You can use the group chat. If you're shy, boleh chat personal dengan cikgu. You can check directly with me and ask. Okay, anything Kalau perlu cikgu ulang, you need me to repeat anything. Okay, don't understand anything, just ask. Right? Okay, come, let's start. Mari kita mula kelas. So we start with, kita mula dengan 6.1. So dalam bab 6 ini, chapter 6 is light and optics, cahaya dan optik. Bab 6 sangat popular. Bahagian B, bahagian C. Section B, section C. This chapter 6 is very popular lah. Very, very popular. Even the latest trend, bab 5 dan bab 6, popular. It's popular. So, this is a very important topic. Alright. Dan dia ada 6 subtopic. There are 6 subtopics. Dalam bab 6 ini ada 6 subtopic. Right? Okay, we start with the first one. Refraction of light. Pembiasan cahaya. Alright. So, dalam bab 5, class chapter 5, we've already done refraction of waves. Kita buat pembiasan gelombang. Okay, tapi kita tak belajar tentang cahaya. We don't learn about light. There's a separate topic here just for refraction of light. Pembiasan cahaya. Okay, so what is the meaning of refraction of light? Apakah maksud pembiasan cahaya? So whenever it is refraction, what is refraction? What's the main thing? Apa yang berlaku semasa pembiasan? Wrong answers are welcome. Awak akan belajar daripada jawapan yang salah. Don't worry. When you think about refraction, what do you think about? Bila saya sebut perkataan pembiasan, awak ingat tentang apa? What does it remind you of? Okay, when you think refraction, you must think bending. Medium berbeza. Okay, very good. Yes, that's an important part of it. You must think bending of wave. Gelombang akan membengkok. Okay. Think refraction, think bending of waves. So, apakah itu pembiasan? What is refraction? Refraction of light here. Light. Pembiasan cahaya ialah is a change in the direction of the light. Perubahan arah perambatan cahaya. Arah perambatan cahaya. Okay, lepas kita nyatakan apa dia, after you state what it is, you have to state how. Because of what? Kenapa? Why does it change direction? Dalam pembiasan, kenapa gelombang berubah arah? How come? Because of a change in the velocity of light. Disebabkan perubahan halaju cahaya. Disebabkan perubahan halaju cahaya. By the way guys, this is a crash course. Ini adalah kursus intensif. Okay, cikgu takkan ajar semua dengan mendalam. I'm not going to teach everything in detail, but we will go through as much as we can. Semua yang penting cikgu akan ajar lah. I'm going to teach you all the important things here. You want to deep dive into everything, then you can go and get the FlexiStudy. Daripada FlexiStudy. But I will teach you as much as I can. Okay. Alright. Nanti cikgu cerita tentang FlexiStudy. Later I tell you about FlexiStudy. Alright, so change in direction due to change in velocity. Dan kenapa pula tiba-tiba cahaya akan berubah laju? Why will it change velocity? Because different medium. Sebab dia merambat melalui medium yang berlainan, ketupatan optik, different optical density. So for example, daripada udara kepada kaca, from air to glass. Air and glass got different optical density. Udara dan kaca ada ketupatan optik yang berlainan. Like that lah. Okay. So when it goes into a medium with different optical density, bila cahaya merambat ke dalam medium dengan ketupatan optik yang berlainan, laju dia berubah, the speed will change, and ini akan menyebabkan dia berubah arah. It will cause it to change direction. Kan? Okay. Okay. So, let's look at this first. This is the refraction. Ini adalah pembiasan cahaya. Right? So, what happens from air to glass? Can you see apabila dia masuk dari udara ke kaca? So, these are two different mediums. Medium yang berlainan dengan ketupatan optik yang berlainan. Different optical density. What happened? Dia sudah bertukar arah. If it didn't change direction, kalau dia tak bertukar arah, sepatutnya dia terus merambat pada arah ini. It should continue to propagate in this direction. Straight. Kan? Lurus macam ni lah. Sepatutnya. But can you see or not? Dia sudah membengkok. It is already bent here. Yes, mendekati garis normal. That's correct. Okay. So, how to explain this? Macam mana kita terangkan dia? First, you explain the different optical densities. Ketupatan optik yang berlainan. So, glass has a higher optical density than air. Okay, kaca mempunyai ketupatan optik yang lebih tinggi daripada udara. Now, ketupatan optik tak sama dengan ketupatan. Technically, it's not the same thing. But usually, biasanya, contohnya air and glass, you know, density of glass is higher lah. Dia perpejal kan. It's a solid. So, optical density also follows the trend. Dia ikut trend yang sama lah. Okay, so what happens? So when lower density to higher density, ketupatan yang rendah ke tinggi. Okay, again, it follows the same trend. So awak boleh ingat macam ni, you can remember like this. If you are walking in air and you are walking in water. Contohnya kalau awak masuk kolam renang dan awak berjalan kan. Awak berjalan macam biasa dalam udara dan bila awak berjalan dalam kolam renang. If you are walking in a swimming pool. Right? Swimming pool density is higher. Air ada ketupatan yang lebih tinggi daripada udara. Right? From the air. So where will you be slower? Udara ke kolam renang? Now obviously you'll be slower in the swimming pool lah kan? Right? Bila awak berjalan dalam kolam renang, mestilah lebih perlahan daripada berjalan dalam udara. Correct or not? Okay? Same concept. Same concept. Ketupatan optik pun sama. Kalau cahaya bergerak dalam objek dengan ketupatan optik yang lebih tinggi, okay, if light moves in a medium with a higher optical density, it will be slower. Memang dia akan lebih perlahan lah. Okay, jadi it slows down. Wait, nanti cikgu terangkan. It slows down here. Cahaya bergerak dengan lebih perlahan apabila memasuki kaca dari udara. Now, when it slows down, what happens? Apabila dia menjadi semakin perlahan. Okay, it will bend towards the normal. Dia akan membengkok mendekati garis normal. Okay. Okay, so again, if you want the full story, you think about tire. You see, katakan ada kereta. I say there's a car. Okay, ini pandangan atas. This is the top view. Ini pandangan atas. Okay, kereta. Tire dia. Bila tire dia baru masuk, for example, let's say Dia masuk dari jalan raya, from the road. Okay, it goes into a very rough place lah. Sangat kasar. Okay. So, okay, mud is the other way around. Cikgu nak terangkan yang lagi satu. Okay. So, because of a different surface here, permukaan yang lain di sini, okay, cuba bayangkan tayar ini lebih perlahan. This tire moves slower. Okay. This tire moves slower than this tire. Faham tak? Sebab tayar ini dia ada dalam medium yang lain. It's in a different on a different surface, pada permukaan yang lain. Understand or not? Okay. So bila tayar ini lebih perlahan, this is the slow tire. Dia berputar dengan lebih perlahan berbanding dengan tayar yang ini. What will happen? Kereta akan pusing ke arah ini, betul tak? The car will turn in this direction, isn't it? Sebab di luar dia lebih laju. This is faster. This is spinning faster. Faham tak? Dia berputar dengan lebih laju berbanding dengan sini. Jadi dia akan putar sini kan? Understand or not? It's the same story. Okay. So, kalau objek menjadi lebih perlahan dalam medium yang baru, if the object becomes slower in the new medium, look at where it is turning. Tengok dia berpusing ke mana. So, this is called the normal. Normal ini sangat penting dalam bab cahaya. The normal is a line, garis yang berserenjang dengan sempadan, with the boundary between the two medium, antara dua medium. Kan? Faham tak? Okay, garis yang berserenjang dengan sempadan antara dua medium. This is the normal line. So, it will always move towards the normal. Dia akan membengkok ke arah normal. Sepatutnya kereta terus bergerak terus macam ni, lurus macam ni, tapi dia akan membengkok ke arah ini pula. It will bend towards the normal. Understand? Faham tak? Okay. So you must remember this. Kena ingat ini, nanti cikgu ada jadual dia. I have a table for you. Okay, so there was a question just now. Macam mana kita tahu ketupatan dia rendah atau tinggi? Now, dalam syllabus kita kelas, in our syllabus we don't have many mediums. Okay. So, dalam syllabus kita biasanya kita ada udara. Air will be the lowest density lah, ketupatan paling rendah. Okay. Then kita ada kaca, we have glass. Okay. Then yang lagi satu ialah perspex. We have perspex. And then kita ada intan, diamond. Diamond will be the highest density. Okay. So, kalau contohnya dia bagi perspex, if they give you something like perspex or something that's not normal lah. So, biasanya udara, kaca, then lepas tu intan. From low to high. Ketupatan rendah ke tinggi. Okay. Air, glass and then diamond. Now, if they give you something odd, kita boleh tahu yang mana ketupatan dia lebih tinggi, ketupatan optik berdasarkan based on the refractive index. Berdasarkan indeks biasan. Nanti cikgu ajar. When I'm teaching about this, I'll tell you all about it. Okay? Right? We refer to the refractive index. But generally, these three, itu turutan dia. That's the order lah. Okay? Okay. So, dia sudah masuk kaca kan? It's bending towards the normal because dari ketupatan rendah ke tinggi, dia menjadi lebih perlahan. It slows down, it bends towards the normal. Now, from here, apabila dia bergerak dari kaca ke udara, when it goes from glass to air again, what happens? So, sekarang, dia tukar medium lagi, changes medium again, but this time, dia lebih laju dalam udara. It's faster in the air, isn't it? Faham tak? Okay. So, what will happen? Apa yang berlaku? Dia akan membengkok, menjauhi normal. Away from normal. Away from normal. Okay, so this one you must remember lah. Mendekati normal ialah apabila dia menjadi perlahan. When it becomes slower, it bends towards the normal. Bila dia menjadi lebih laju, when it becomes faster, it bends. Okay, when it becomes faster, it bends away from the normal. Menjauhi normal. This one you have to remember. You can remember the tire story lah yang cikgu bagi tahu tadi. Kan? Boleh? Okay. The arrow, no, arrow is arah perambatan. arah perambatan cahaya. Arrow, this one actually ialah sinar dia lah. Sinar cahaya. The ray. The ray. Okay, another thing you all have to know class tentang sudut dia. We are going to learn the angles. Sudut dia, bila kita ukur sudut, when we measure angles in this chapter, it's a very common mistake. Okay, pelajar selalu ambil sudut ini. Okay, salah. This is wrong. Bila kita ukur sudut dalam bab ini, in this topic, when we measure angles, we always measure with the normal. Kita selalu ukur dengan normal. Okay, you always take measurement with the normal. Just remember that first. Nanti cikgu terangkan lagi. Okay, now, what is refractive index? Apakah itu indeks pembiasan? So, indeks pembiasan ialah nisbah, is a ratio. Indeks pembiasan ialah nisbah, is a ratio of the speed of light. So, nisbah laju cahaya dalam vacuum, speed of light in the vacuum, ke laju cahaya dalam medium, to the speed of light in the medium. So for example, kalau kita nak nisbah, kalau kita nak indeks pembiasan kaca, if you want the refractive index of glass, how do you define that? Itu adalah, indeks pembiasan kaca adalah nisbah laju cahaya dalam vacuum, the ratio of the speed of light in vacuum to the speed of light in the glass, kepada laju cahaya dalam kaca. Nisbah dia. Kan? Okay. Alright. So, refractive index ada banyak rumus. There are many formulas. Ada banyak rumus. We are going to learn all of them. So first is Snell's law, hukum Snell. Now what is Snell's law? So indeks pembiasan, okay wait, we use the definition first. Kita guna definisi dulu lah. We use the definition first. The speed of light here. Tengok ni, laju cahaya. So menurut definisi kita, according to our definition, refractive index is what? The ratio. Nisbah apa? Laju cahaya dalam vacuum. Speed of light in vacuum is C. Okay. Kepada to V. V ialah laju cahaya dalam medium. Right? So N is the refractive index. N ialah indeks pembiasan medium. C is the speed of light in vacuum. V ialah laju cahaya dalam medium. This is the definition. Inilah definisi indeks pembiasaan. Okay. Alright, tengok contoh di bawah. Look at the example here. So again, ini adalah kursus intensif. This is crash course. Okay, nota sebenar cikgu, my normal notes, nota normal cikgu ada banyak soalan lagi. There's a lot of questions. Okay, so this one is just crash course. So cikgu bagi contoh. I give you an example. So kita at least berlatih sekali lah. Okay, refractive index. Example 1. Tengok contoh 1. Diberi speed of light in diamond. Dalam intan ialah ini. Ini laju cahaya dalam intan. So what is this? Medium kita di sini ialah intan. Diamond is the medium. Okay, and this is the speed in the medium. Laju dalam medium kan? Which means ini ialah V lah. Correct or not? V is 1.24 darab 10 kuasa 8 meter per saat. Okay, calculate the refractive index of diamond. Hitungkan indeks biasan intan. Right? So how? So di sini, since dia sudah bagi laju cahaya dalam intan, they gave us the speed of the light in the diamond, we can use N ialah C per V. C is a constant and it will be given to you. C adalah pemala dan memang diberikan. Okay, jangan risau. C is this one. 3.0 times 10 kuasa 8 meter per second. Yes, very good. Okay. So, bila kita nak, okay class, this is important. So, kalau kita nak indeks pembiasan intan, if you want the refractive index of diamond, okay, then we need to use the speed of light in diamond. Laju cahaya dalam intan. If glass, glass. Kalau perspex, perspex macam tu. Okay, Okay, now kita ganti saja. Just substitute lah. So, C will be 3.0 darab 10 kuasa 8 10 to the power 8 3.00 3.00 bahagi dengan V. So 1.24 1.24 darab times 10 kuasa 8. So by the way class, laju cahaya paling tinggi dalam medium apa? The speed of light will be the highest in which medium? Air. Okay, good. Close, very good. The answer is no medium. Vacuum. Okay. Bila tak ada zarah, langsung tak ada zarah, there's no particles at all, that's when the speed of light is the highest. Laju cahaya paling tinggi dalam vacuum. Now, when they say in air, okay, bila dia kata dalam udara, normal, tak faham yang mana? Laju cahaya. Laju cahaya paling tinggi dalam vacuum. Vacuum ialah apa? What is vacuum? Vacuum ialah satu ruang yang kosong. Empty space. Kosong. Zarah udara pun tak ada. There's no air particles also. Zero matter. Right? Bukan, okay. Okay, very good. Good logic. But the problem is, cahaya ini, dia bukan terdiri daripada zarah, betul tak? But we are going to learn the opposite in chapter 7 lah. Tapi apabila cahaya merambat, when light is travelling, when light is propagating, it moves as a wave. Dia bergerak sebagai gelombang. So, tak ada zarah. There's no particles. Okay? Tak ada zarah. So, no, it's not because of air resistance lah. It's just that itulah that's when there's nothing, that's when it moves the fastest. Okay? Pada masa itu dia bergerak dengan laju yang paling tinggi. Right? So, now, a lot of times, soalan akan bagi laju dalam udara. The speed in air, we assume is the same as the speed in vacuum. Laju dalam udara, sometimes ada masanya yang kita memang anggap yang laju dalam udara sama dengan laju dalam vacuum. Because perbezaan dia tak banyak. The difference is not much. Okay? You may have to assume. Just keep in mind. Vacuum dan udara hampir sama. Can Okay? Just keep in mind. Alright, another thing. Since laju dalam vacuum adalah laju paling tinggi, the speed in vacuum is the highest, your refractive index will always be more than 1. No, there's no unit. Very good question. There is no unit because this is a ratio. Nisbah tak ada unit. Okay, so again, because this value ini adalah nilai paling tinggi, your refractive index must be more than 1. Kalau awak dapat jawapan indeks pembiasan kurang daripada 1, memang sudah salah. Something is wrong already. Check your calculation. Okay, semak balik perhitungan awak. Mesti salah. Refractive index, no. Refractive index normally we give an 2 decimal places. 2 tempat perpuluhan untuk indeks pembiasan. That's normally how we give refractive index lah. Okay, can? Okay, so now we go to Snell's law. Ini kalau kita ada laju cahaya dalam medium. This is if we have the speed of light in medium lah. Okay, now Snell's law. Okay, Snell's law. Snell's law is the ratio of the refractive index between two medium. Nisbah Nisbah indeks pembiasan antara dua medium. So this is another medium. One medium, one medium, one medium, one medium 2 lah. Medium 1, medium 2. Okay. Nisbah indeks pembiasan dia ialah okay, sine of theta 1 to sine of theta 2. Dia terbalik is the other way around Okay, dia terbalik. Ini 2 1, ini 1 2. Okay. So, when we multiply the denominators, bila kita darab persamaan ini dengan penyebut what we will get is, apa yang kita akan dapat ialah N1 sin theta 1, N1 sin theta 1 ialah N2 sin theta 2. Okay, so clearly your next question is, apa itu 1, apa itu 2? Right? Obviously lah. What is 1, what is 2? So, dia ikut medium. The number follows the medium, the angle in the medium. So, ingat tak, balik kepada sini kelas. Go back here. Go back here. Okay. So, remember I told you, kita memang kena ambil sudut dengan normal. You always have to take the angle with the normal. Please remember this. This is the most common mistake. Kesilapan yang sering dilakukan. Okay. So, when we take the angle with the normal, so, katakan udara ialah medium 1. Let's say air is medium 1. So, ini adalah theta 1 lah. Faham tak? Understand or not? Understand or not? Okay. Kalau kaca ialah medium 2, if glass is medium 2, then this is theta 2 lah. Understand? So, Snell's law is N1, N1 sin theta 1. That means, indeks pembiasan untuk udara darab dengan sin sudut ini will be equals to indeks pembiasan untuk kaca, the refractive index for glass times sin theta 2, which is this angle. Faham? Okay? Okay. Next. Okay, wait, we write all this first. What is N1? What is N2? Okay, N1 is the refractive index of medium 1 lah. Contoh tadi ialah, the example I gave you all just now is air. N2 will be the second medium. Medium yang kedua. Medium 2. Okay. Now, theta 1 will be angle of incidence, sudut 7. And angle 2 will be angle of refraction. Okay, so we got two new terms here. Angle of incidence, sudut 7, angle of refraction, sudut pembiasan. What is this? Angle of incidence is the angle before refraction, sebelum pembiasan. Okay, that means kalau dia masuk dari 1 ke 2, if it's coming from 1 to 2, okay, kalau dia masuk dari 1 ke 2, this will be angle of incidence. Ini adalah sudut 7. Understand? Sebelum pembiasan, before the refraction. Then, what is angle of refraction? Apakah itu sudut pembiasan? Angle of refraction is after the refraction. Selepas pembiasan, itu ialah sudut pembiasan lah. Faham tak? Okay. Can Okay. Now, there is another special adaptation of Snell's law. Okay. Hukum Snell ini, kalau medium 1 ialah udara, if the medium 1 is air, and this is the most popular formula that we use. Ini adalah formula yang paling banyak kita guna. Okay, if medium 1 is air, sudut 7 kat luar, tak semestinya. Tengok arah perambatan sinar cahaya. Look at the direction of propagation of the light ray. Right? So, contohnya, okay, for example, light ray can travel, dia boleh merambat dari bawah, from inside here, and then dia keluar sini. Okay, so mana sudut 7? Where is the angle of incidence? Sudut 7, tengok arah perambatan dia. Ini adalah sinar sebelum pembiasan, betul tak? This is before the refraction, correct or not? So, where is the angle of incidence? Sudut 7 di sini. Faham? Understand? Then sudut pembiasan, angle of refraction will be here. Okay. Derive formula for this chapter? No, don't have. Don't worry. Not that I know of lah. No, it has never happened as far as I know. Okay, so Snell's law, when medium 1 is air, apabila medium 1 ialah udara, okay, what will happen here? So N2 bahagi N1, N1 is sin theta 1 per sin theta 2, sin theta 2. Okay, please listen very carefully. Dengar baik-baik. So sini, this situation is apabila let's say dari udara from air, udara kepada kaca, glass. Okay, so from air, dia merambat ke dalam kaca into glass. So ketupatan optik kaca lebih tinggi, so it will be reflected towards the normal lah. Okay, mendekati normal. Again, when it's slowing down, it moves towards the normal. Bila dia menjadi semakin perlahan, dia mendekati normal. Okay, so this angle, it's coming from the air. Dia datang dari udara. So this will be angle 1, sudut 1 lah. This is also labeled as I. Kita juga label sudut 1 ini sebagai I, because ini adalah sudut 7, incident angle. Understand? Okay. Kenapa ini sudut 7? Sebab ini sebelum pembiasan, before the refraction, isn't it? Okay. This one will be theta 2. Ini adalah theta 2. Okay. This one we also label it as R. Kita juga menggunakan R di sini because this is angle of refraction. Sudut pembiasan. Angle of refraction. So R. Kan? Faham? So apabila theta 1 ialah dalam udara. When theta 1 is in air, okay, apakah indeks pembiasan untuk udara? What is the refractive index for air? Remember what I told you just now? Okay, N ialah C per V. Ingat tak apa yang cikgu bagi tahu awak tadi? We do assume that the speed in air is the same as the speed in vacuum. Kita memang anggap dia sebagai sama. Perbezaan dia tak banyak. Remember what I told you just now? Okay. So kalau sama, apakah nisbah dia? What is the ratio? What's the value of the ratio? Kalau sama. Yes, very good. Kalau sama, 1 lah. Betul tak? 1 lah. Sama kan? It's the same. 1 lah. Okay? Kan? So, refractive index of air, indeks pembiasan udara, iaitu N1. Remember this is medium 1. Ini medium 1 ini medium 1 This is 1. Okay. So, this one will become N2 bahagi 1. Okay. Now, theta 1 ialah apa tadi? The theta 1 will be incident angle, isn't it? Sinar 7. And then, theta 2 will be, theta 2 ialah sinar pembiasan, refracted angle. Sudut pembiasan. Sudut 7, sudut pembiasan. Kan? Understand? So, this is where we get the formula. Di sinilah kita dapat rumus. N equals to sin I over sin R. This is the most popular formula yang kita pakai untuk indeks pembiasan that we use for refractive index. N ialah sin I over sin R. Tapi ada satu syarat. There is a condition. I must be in the air. Mesti dalam udara. I mesti dalam udara. Angle of refraction. Okay, come. That's why cikgu ada ini di sebelah sini. Come. N is what? Refractive index of the medium. Indeks pembiasan medium. So, in our example, it will be the glass. Dalam contoh tadi ialah kaca. Apakah indeks pembiasan kaca? What is the refractive index of glass? we can use sin I over sin R. Kita boleh pakai sin I per sin R, tapi but the condition is I mesti sudut 7 dalam udara. Angle of incidence in the air. Okay. R is the angle of refraction in the medium. Mesti dalam medium. Mesti dalam medium. It cannot be the other way around. Okay, okay. Let me test your understanding. Okay. Kita uji pemahaman anda, cikgu uji pemahaman awak. Let's say ini intan, diamond. Intan. Ini udara, this is air. Okay. Light is coming, cahaya merambat propagates from the diamond. Dia datang dari intan. Okay, then dia keluar ke udara. It comes out in air. So, when it comes out to air, it's moving faster. Dia bergerak dengan lebih laju, jadi dia menjauhi normal. It moves away from normal because it's moving faster. Okay. Let's say this is A, ini B, ini C, dan ini D. What is N? Guna hukum Snell. Apakah indeks pembiasan untuk intan? Guna hukum Snell. Use the Snell's law. No. Apakah N? So the formula is, rumus dia ialah, the formula is, N ialah sin I over sin R. N ialah sin I per sin R. Right? Very good. Very good. So mana sudut pembiasan dia? Where is the incident angle? Incident angle will be sebelum pembiasan. Here, isn't it? Sini kan? A, isn't it? A is the incident angle, right? Where is the angle of refraction? Mana sudut pembiasan? Lepas pembiasan, R ialah C. Okay, good. So, what's the answer? N ialah sudut pembiasan untuk intan for diamond is sin A over bahagi sin C. Salah. Why? Because kalau kita nak guna bentuk ini, if you want to use this form of Snell's law, okay, I mesti sudut dalam udara. I must be in air. Mesti dalam udara. Mesti. So in this case how? Macam mana kita dapat dalam contoh ini? Sebab dia merambat dari intan. It's coming from the diamond. How are we supposed to know? So dia macam ni kelas. Kalau intan, okay, kalau sinar cahaya menggunakan lintasan ini, dari intan dia keluar ke udara, dia menggunakan lintasan ini. If it use this path, apabila dia merambat dari udara, if it is coming from air along the same path, menggunakan lintasan yang sama, bila dia masuk ke dalam intan, when it goes into the diamond, it will follow the same path. Dia akan ikut lintasan yang sama juga. Di sini dia akan bergerak ke arah normal, isn't it? It will move towards the normal, right? Dia akan dibiaskan ke arah normal. It will be refracted towards the normal, isn't it? It will follow the same path. So, walaupun dalam contoh ini sinar cahaya memang dia datang dari intan, it coming from the diamond, but we also know, kita juga tahu, kalau dia datang dari udara, dia akan ikut lintasan yang sama. So, now, sin I sepatutnya kita pakai, we should use sin C. Ambil ini sebagai sudut 7. Faham tak? You take this as the incident angle. Sin C bahagi sin A. Yes. Boleh kelas? Understand or not? Faham tak? So when we are using sin I over sin R, bila kita pakai sin I, sin R, awak mesti ingat I itu kita kena ambil sudut dalam udara. Angle in the air. Okay. Tapi kalau kita guna hukum Snell yang lagi satu, if you are using this one, kalau awak pakai yang ini, it doesn't matter. Tak kisahlah. N yang mana satu, N yang mana dua, it doesn't matter. It can be without air also. Mungkin antara kaca dengan air contohnya. Between water and glass. It doesn't matter. Okay, come, let's try Snell's law. Tengok contoh 2. Diagram on the right shows refraction of pembiasan sinar 7 incident ray as it passes through glass and water. Dia melalui kaca dan air. Okay, hitung indeks pembiasan air. Calculate the refractive index of water. Okay, so kita nak indeks pembiasan air. You want water. How? So kita ada sudut dia. Kita ada sudut ini. We have this angle here. What else? No, biasanya taklah. Awak boleh guna yang mana yang sesuai. You can use any of the formulas for refractive index. Normally, they don't ask you to use a specific formula. Awak tengok keadaan lah. Tengok apa yang diberikan. Look at what is given. And then gunakan rumus yang berkenaan. Okay. Class index for... No need. Actually, no need. Tak perlu. Okay, Ken. Yes. Yes, Ken. Ken. Okay, yes. We can find refractive index of glass first. Boleh. Sin 34 over 2. Sin I over sin R. Okay. Can we use sin I over sin R here? Boleh tak? Yes. Okay, very good. Okay. See, first of all, class, look at this angle. You remember your angles. You remember your Z shape. Kita ada dua garis selari di sini. Two parallel lines here, right? This is a transversal. So kalau ini 29, if this is 29, this is also 29.3, isn't it? Sama kan? 29.3, Remember or not? Two parallel lines. Garis selari. Sudut ini sama dengan sudut ini, betul tak? Same angle, 29.3 here. Okay. So kalau kita pakai yang ini, which one you're going to use? Okay, very good. Okay, very good. Almost. Tak ada siapa yang ada jawapan betul sekarang. Almost. Okay, you see. If we want to use, kalau kita nak guna hukum Snell. So this one, let's say you want to use Snell's law. So what we have now? Kita ada sudut. We have this angle in the glass, kaca. Okay, sebelum dia masuk air. Before it goes into water. 34 here. And then we have this angle here, 42 di sini. Now, very good. Yes, okay. Now, class, listen, kalau dia datang dari udara, if it comes from air at this angle, okay, dan dia masuk kaca, bila dia masuk kaca, when it goes into the glass, it bends this way. Dia membengkok sampai sudut dia 29.3 lah. Lepas tu, bila dia keluar sini, when it comes out here, the light ray goes at an angle of 34 degrees. But, kalau kita alihkan kaca ini, if you remove the glass, dan sinar ini merambat terus dari udara ke air. If it straight away goes from air to water, it will still follow the same path. Maksudnya, kalau dia pergi dari udara ke kaca, from air to glass, it will still be, kalau dia masuk sudut 40 darjah, if it enters at a 42 degree angle here, dia masih lagi dalam air, in water, okay, it will still be 34. Dia masih lagi 34. It will still be 34. Understand or not? Okay. So, we can ignore the glass. We can ignore the glass. Right? Okay. What is the other way? Apa cara yang lagi satu? Okay, kita buat dua-dua. We are going to do both ways. I want to show you yang kita akan dapat nilai yang sama. So, let's say we have, so now because it's between glass and water, kaca dan air kita tak boleh guna. You cannot use sin I over sin R. Cannot. Because kalau sin I per sin R, I mestilah sudut dalam udara. It must be the angle in air. Must. Kan? Okay? So we cannot use this. Kita tak boleh pakai ini sekarang. Okay? So now we have to use kaca dengan air. Glass and water lah. Right? So glass and water, kaca dengan air, no, that one is a different story. We don't have the C value here. Now, glass and water, kita kena, so we have to use N2 over N1 lah. Betul tak? We have to use this formula, right? N2 per N1 sama dengan is equals to sin theta 1 per theta 2 over theta 2. Correct? We have to use this one. Kita guna hukum Snell. Yang asal, the original one, isn't it? Yes, very good. You understand? Class faham? Understand? Okay. So let's take water as 2, kaca sebagai 1 lah. Okay, let's try this. So, apakah indeks pembiasan untuk air? Itulah apa yang kita nak cari. We want to find the refractive index of water. So, we want to find this. Okay, kita letak N2. Now, what is the refractive index of, okay. So, kita darab dulu. You multiply, we take this form. Kita ambil bentuk ini lagi senang. Actually, kalau kita jadikan N2 sebagai perkara rumus, it will become N1 sin theta 1 over sin theta 2, right? Darab dengan N1 lah, multiply by N1, okay? So, kita dapat N2 sebagai perkara rumus, which is what we want to find. Okay. So, what is the refractive index? So, apakah indeks pembiasan bagi kaca? What is the refractive index of glass? Now, ini dia tak bagi kan? Tapi kita boleh cari, betul tak? We can find. Because we have the angle of refraction here. Okay. Kita ada sudut pembiasan di sini. Dan kita ada sudut tuju dalam udara. We have the refractive, we have the incident angle in air. Sebab medium di sini ialah udara. Can you understand that? Ini adalah dia masuk dari udara ke dalam kaca. From air into glass, isn't it? Now, kalau salah satu medium dia udara, we can use, memang kita boleh pakai sin I over sin R. Betul tak? So, that means kita memang boleh pakai sin I per sin R untuk kaca. For the glass can, boleh. Can. Understand not, class? Faham tak? For the glass can. So, here, gunalah. So, N1 ialah, okay, this will be sin, okay, this is where, I told you, right, mesti awak melakukan kesilapan di sini, right? Very high chance you'll make a mistake here. And a lot of you did, right? Ingat tak cikgu bagi tahu tadi, bila dalam topik ini kita ambil sudut antara sinar dengan, we have to take the angle between the ray and what udara dengan, sinar dengan normal. Dengan garis normal. You cannot take this. Kita mesti ambil sudut dengan normal. Whatever it is, the angle you always take with the normal. Right? Dengan garis normal. So, apa sudut ini? Ini 42. This is 90 degrees. 90 darjah. Jadi, 90 tolak 42. Understand? 90 minus 42. So, sudut tuju dia ialah 48. 48. Yes. Okay. So, this will be sin 48. Sin of 48. Okay. Over sinar pembiasan. This one 29.3. Check again. Adakah dia dengan normal? Yes. Yes, it is. So, it will be over sin 29.3. Can faham bahagian ini kelas? Do you understand this part? Okay. Alright. Then kita darab dengan sin theta 1. Theta 1 is what? 29.3 because kaca 1 kan. So this is theta 1. So darab dengan sin 29.3. Right? Bahagi dengan what is theta 2? Here. Sin. Check again. Adakah dia dengan normal? Is it with the normal? Yes. Okay. Boleh lah. So sin 34. Okay lah. Boleh tak? Kurang faham? Can. Okay. Come. Let me repeat. Cikgu ulang. So, there are few parts to this. Nombor satu ialah kita nak cari indeks pembiasan air. We want to find the refractive index of water. So, kita kena tengoklah air, sudut dia. Kita ada sudut apa? What angle do we have? So, kita ada sudut dalam air. We have the angle in the water. Antara sinar cahaya dengan normal dalam air. Yes. Lagi satu ialah dalam kaca. The other one is with glass what? Correct or not? Bukan udara. We don't have with air. Can you understand that? Faham tak? Tak ada dengan udara. Okay? Boleh? So how? So, kalau tak ada dengan udara, we cannot use, kita tak boleh guna sin I per sin R. Cannot. Kalau kita nak guna sin I per sin R, if you want to use sin I over sin R, it has to be with air. I must be air. I mestilah udara. Tak boleh. So, we already know, kita kena pakai hukum Snell. You have to use the Snell's law, the original one, which is this one. N2 per N1 is sin 1 over sin theta 2. Right? Okay. Jadi, kita nak air, indeks pembiasan air, water, which we label as 2. So, N2 lah. We want N2, isn't it? So, kita jadikan dia perkara rumus. You multiply the whole thing by N1. Darab dengan N1. Darab dengan N1. So, kita dapat N1 sin theta 1 over sin theta 2. Boleh? Okay. So, dari sini, from here, okay, sin theta 1, okay lah. Theta 1 ialah sudut dalam kaca kan? This one lah, 29.3. Right? Okay. Then selepas pembiasan, 2 ialah air, 34. So, ini 34. Boleh? Faham tak ini? This one and this one, okay? Kan? So, N1 ialah apa? What is the N1? Medium 1 ialah kaca. Indeks pembiasan kaca. How do we get the refractive index of glass? Right? Now, kaca, okay, glass, let's look at glass. Kita ada sudut dalam kaca, in the glass. Look at this refraction here. Tengok pembiasan di sini. Look at the refraction here. Kita ada sudut dalam kaca dan kita boleh dapat sudut dalam udara. We can get the angle in the air. Salah satu sudutnya ialah udara. One of the angle is in air, dalam udara. Which means, maksudnya, kita boleh pakai, you can use sin I over sin R. Understand or not? Faham tak? Okay, because salah satu sudutnya ialah dalam udara. But of course, kita tak boleh ambil sudut 42 because dia bukan dengan normal. You have to take the angle with the normal. So, sudut di sini 90 darjah. Antara normal dan sempadan. Between the normal and the boundary is 90 degrees. 48. Excuse me. 90 tolak 42. 90 minus 42. Faham? So, this will be your incident angle. Ini ialah I lah. Faham tak? Sebab ini dalam udara kan? Because it's in the air. Okay? R ialah selepas pembiasan dalam kaca ialah 29.3. So, this is R. So kita guna sin I per sin R di sini. This one. Ini ialah sin I bahagi sin R untuk cari indeks pembiasan kaca. Yes, boleh. Bukan potonglah, bahagi. Yes, boleh. Boleh bahagi. Faham tak? Can understand or not? Jelas kelas? Everybody okay? Alright, okay. Everybody else okay? Yang lain semua faham? Kan? Okay, so di sini kelas, bila kita bahagi, you divide. Bahagilah 1. So, kita dapat sin 48. Sin 48 over sin 34, right? Okay. So, jawapannya, now you have to use your calculator lah. Awak akan dapat sin 48 bahagi sin 34 1.32895 1.33 1.33. Okay, so this is kalau kita guna hukum Snell tanpa melibatkan sudut dalam udara. If you use Snell's law without involving the air, this one. Now remember I told you just now, ingat tak saya cikgu bagi tahu awak tadi, actually kalau kita buang kaca ini, if you remove the glass and the light travel straight away from the air to the water, kalau cahaya merambat terus dari udara ke air, dia akan ikut sudut yang sama. It will follow exactly the same angle. That means dari udara from the air, okay, udara di sini 42. This is 48. We already calculate. Ni 48. Kalau dia terus masuk ke dalam air, if it straight away goes into the water, sudut dia memang akan kekal sebagai 34. The angle will be 34. 2 decimal. Refractive index we always use 2 decimal. Understand or not? Dia akan kekal sebagai 34. So kalau kita boleh buang kaca, if you can just ignore the glass, then nampak tak salah satu sudutnya ialah dengan udara. Can you see that one of the angles is with air? Nampak tak? It doesn't change because memang itu adalah arah perambatan dia. Okay, you think of it like this lah. Awak bayangkan macam ni. Okay. Sebelum dia masuk ke dalam air, before it goes into the water, dia keluar dari kaca dulu, betul tak? It comes out of the glass. So, sini dia masuk 48. Here it goes in 48. So, sini, here, 29.3, 29.3. Okay. So, sini pun samalah, 29.3. Okay. Then, apabila dia keluar balik, when it comes back out into the air, right? Sudut ini, dia akan balik kepada 48. It will go back to 48. Understand or not? Faham tak? Dia 48 lagi. It will be the same angle here. Bila dia keluar balik, dia keluar 48. Comes out as 48, right? So, apabila dia masuk air sekarang, when it goes into the glass, 48 lah. Understand? Bila dia masuk air, when it goes to the water, this is the glass. Ini kaca. Bila dia masuk air sekarang, 48 lah. Faham tak? You can think of it like that. Bila dia keluar balik ke udara, memang dia akan masuk dari 48. 48. So, dia masuk udara seolah-olahnya dia terus masuk ke dalam air. It's as if it straight away goes into the water at 48 degrees. Okay? Memang dia macam tu lah. That's how it moves. Okay. So, kalau kita buang kaca, you get rid of the glass, then we can use N sama dengan sin I per sin R. That is the beauty of it. Right? Kalau kita buang kaca, we can use sin I over sin R. Jauh lebih senang kan? Right? Tak ada apa. Dia mempengaruhi laju cahaya. Dia akan menjadi lebih perlahan, jadi dia akan membengkok lah. It will bend because it's moving slower. It will bend towards the normal. Laju, speed and direction. Okay, so di sini kita boleh terus guna. You can straight away use sin 48 lah. 48 because sinar 7 mesti dalam udara 48 over sin 34. Can you see? Nampak tak? This is exactly what is happening here. Same. Sama. Sama je. Boleh. So 1.33. Kan? Okay. Okay, there's one more formula. Ada satu lagi rumus untuk indeks pembiasan. One more formula for effective index, which is this. Real depth, apparent depth. Dalam nyata, dalam ketara. Okay, now the formula here is, sama. So here is, biasanya kalau ni keluar dia objektif lah. Capital D over small d. D huruf besar, D huruf kecil. Apa itu D huruf besar? Apa itu D huruf kecil? What is the capital D? What is the small d? So, N is of course refractive index. N indeks pembiasan. Capital D, D huruf besar ialah real depth. Dalam nyata. Okay. D huruf kecil, small d, apparent depth. Dalam ketara. So, what is this real depth and apparent depth? Apa itu dalam nyata, dalam ketara? We will see in a while. Okay. Okay. Go back down class. Tengok sini. Dalam nyata, dalam ketara. So, ini adalah apabila kita melihat objek yang berada dalam medium yang lain. Okay, when we are looking at an object in another medium. Contohnya, bila kita melihat ikan dalam air. When we are looking at the fish in the water. Okay. Now, awak kena ingat, how our mind works is, okay, cara otak kita berfungsi ialah garis bergerak dalam garis lurus. Cahaya bergerak dalam garis lurus. Light moves in a straight line. So, kalau kita nampak sesuatu di depan mata kita, if you look at something in front of your eyes, that means if you see something, kalau kita nampak sesuatu, it is in front of you, directly in front of you. Dia berada pada satu garis lurus depan awak. A straight line lah, in front of you, is in a straight line. Itu adalah persepsi otak kita. That is the perception of our brains. Okay? But, bila cahaya merambat dari contohnya air kepada udara. Okay? What is happening? Adakah dia menjadi lebih perlahan atau lebih laju? Faster or slower? Air ke udara? Come on guys. Air ke udara. From water to the air. Faster or slower? Di mana dia lebih laju? Faster lah. Sebab masuk udara kan? So kalau lebih laju, dia akan membengkok ke arah mana? It will bend where? Towards normal or away normal? Away from normal. Menjauhi normal ke mendekati normal? Away. Yes. Menjauhi normal. Menjauhi normal. Very good. So, it's going to move away from normal. Jadi, memanglah dia tak boleh bergerak dalam satu garis lurus. It cannot. Impossible. It cannot move in a straight line. Cannot. Sebab, di sini dia tukar medium. It's changing medium. Dia akan menjauhi normal. Okay? So, what actually happens is, okay, now I'm going to teach you how to draw. Cikgu akan ajar macam mana nak lukis. When you get diagram like this, cara untuk lukis ialah, this is the object. So, mana dia akan nampak ikan? Where will this person see the fish? Right? So, you draw the image directly above the object. Lukis image di atas kedudukan atas objek. Draw the same size. Size yang sama. Lukis di atas objek. Di kedudukan atas objek. This is the image. Okay, ini adalah image dia. So, mata kita, our eyes, you draw a straight line, garis lurus, excuse me, dari mata ke, pilih satu titik dalam objek, dalam image. Choose a point on the image lah, any point. So, cikgu pilih mulut dia. I'm choosing the mouth of the fish. Now, bahagian dalam air ini guna garis putus. In the water, you use dash line. please use pencil to draw. Okay. So bila mata kita nampak ikan, when I see the fish, okay, bagi kita dalam otak kita, in our brains, ikan berada pada dalam pandangan kita ialah garis lurus lah, straight line. Ikan berada di sini, the fish is here. Okay, itu adalah persepsi minda kita, because our mind is used to light travels in a straight line. So dia mesti ada di sana. It's right there. If I follow this line, ikut garis ini, pandangan ini, dia di sana. It's there. Faham tak? But actually ikan di mana? Actually cahaya datang dari bawah. Actually the light is coming from down. Cahaya, persepsi kita ialah seolah-olahnya dia datang dari sini, as if it's coming from here. Tetapi sebenarnya in actual the fact is actually it's coming from down. Dia datang dari bawah. And kenapa dia datang dari bawah? Why is it coming from down actually? Let's see. So this is the boundary. Ini adalah sempadan antara air dan udara. Draw your normal line. Okay. Can you see? Nampak tak? Cahaya yang datang dari ikan ini, the light that is coming from the fish, can you see is going to be bent away from the normal? Dia akan membengkok menjauhi normal. Betul tak? Sebab dia bergerak dari medium dengan ketepatan optik yang tinggi ke rendah. So the speed will increase. Laju dia meningkat. When it become faster, it bends away from the normal. So the solid line is the actual path of the ray of light. Ini adalah lintasan betul sinar cahaya. Tetapi garis putus ini, the dash line here, is our perception. Persepsi minda kita. Faham tak? Understand or not? Understand or not? So this is why, dan sebab inilah kita ada, this is exactly why we have real depth and apparent depth. Kita ada dalam nyata, dalam ketara. Real depth will be, dalam nyata ialah the actual depth of the fish. Dalam sebenar dia lah. Until here. Sampai sini. Okay, ini dalam nyata. Apparent depth, dalam ketara ialah persepsi kita, is our perception. Here. Sampai sini. Ini adalah dalam ketara. Apparent depth. Faham? Okay, you draw yourself image untuk duit shilling ini, the coin. Lukis image dia. Draw the ray diagram. Sina, gambar aja Sina. There's actually an experiment here class untuk dalam nyata, dalam ketara, dan untuk indeks pembiasan for refractive index also, sin I, sin R. There's an experiment. Pergi baca go and read in your textbook. Tapi the index pembiasan sorry, menggunakan block kaca using the glass block sudah keluar dalam SPM, already came out in SPM. That one already sudah keluar. So kebarangkalian dia keluar sekali lagi is not high. Bukan mustahil, not impossible, but very low lah. But dalam nyata, dalam ketara belum keluar. The real depth, apparent depth one hasn't come out. It hasn't come out. Okay, are you done? So what's your first step? Lukis image dulu. You draw the image first. Lukis image di atas objek, above the object. Okay, anywhere above the object. Mana-mana kedudukan di atas objek. Okay, then you choose one point, satu titik dari image, terus ke mata, straight to the eyes. Okay, bahagian dalam air ini, the part in the water, make sure you use dotted line. Guna garis putus, dash line. Okay. So dia merambat ke mata, it goes to the eyes. Baru kita boleh nampak. Only when light is reflected from the object into our eyes, we can see the object. Can we see the object? Right? Kita hanya boleh nampak objek jika cahaya dipantulkan dari objek ke dalam mata kita. Okay. Then from here, sempadan dia at the boundary, pada sempadan dia, draw a straight line to the same point on the object. Lukis garis lurus kepada titik yang sama pada objek. This is the actual path. Ini adalah lintasan sebenar dia. Boleh? And okay, let's write the explanation, penerangan dia. So now whenever you explain class, bila kita bagi penerangan tentang ini, you start with the optical density, ketupatan optik, because ini akan mempengaruhi laju cahaya. This is the one that will affect the speed of the light, right? So we start with ketupatan yang mana lebih tinggi, which one is higher lah. So water has a higher optical density than air. Ketupatan optik air lebih tinggi daripada udara. So what is the effect? Apa kesan dia? Apabila dia masuk ke udara, when the light enters the air, it will speed up. Dia akan bergerak dengan lebih pantas apabila memasuki udara dari air. And it is because of this change in speed, disebabkan oleh perubahan laju inilah, it will bend away from the normal line, membengkok menjauhi garis normal. This is how you explain. Inilah isi-isi yang awak perlu berikan. Faham? Logic dia, you understand the logical, the flow of the logic here, right? Start with optical density, mula dengan ketepatan optik, yang mana lebih tinggi, yang mana rendah, which one is higher, which one is lower, and then connect it to the speed, kaitkan dengan laju, and then link it to the direction, arah. So finally, kesan dia, the effect, you end with the effect. So the image appears closer to the water surface. Image akan kelihatan lebih dekat dengan permukaan air daripada kedudukan sebenarnya. From the actual position, it will look closer. Boleh kelas? Can? Understand? Any questions here? Ada soalan? Okay. Okay, tengok contoh 3. Look at example 3. Okay, good. Now, height of liquid K, ketinggian cecair K dalam sebuah cawan in a cup is 5 cm, 5 cm. Okay. A coin is placed in a cup. Sekeping 2 shilling diletakkan dalam cawan. If the refractive index of the liquid K is 1.25, jika indeks pembiasan cecair K ini ialah 1.2, 1.25. Alamak. Okay, 1.25. Hitung ketinggian image. Calculate the height of the image. First thing is first. Okay, di sini dia guna ketinggian. They are not using depth. You must be very clear. Awak kena jelas. Apa ketinggian dan apa kedalaman. What is height and what is depth. Must be very clear. Okay. So, bila kita ada objek yang terendam, and we have an object that is immersed, contohnya, okay, let's use the cup, cawan. Okay, so we have a cup. Dalam cawan ini ada cecair K, liquid K in the cup. Okay. Okay. So dia kata ketinggian cecair, the height of the liquid is 5 cm. That means dari dasar ke, from the base to the surface. Dari dasar ke permukaan ialah 5 cm. Understand? Ini ada ketinggian cecair lah dalam cawan, betul tak? Okay. Then the coin is in the cup. Duit shilling dalam cawan. Ayuh. Duit shilling sudah bengkok. Okay. Then mana image dia? Yes, betul. Udara lebih laju. Mana image dia? Okay. Good try, no. Image dia di atas, okay. So the image is up here, Image di atas ini, Okay. So what did they say? So dia bagi indeks pembiasan, refractive index of K 1.25. Okay. And then we want to calculate what? Kita nak hitung ketinggian image. Height of image is where? Height of image will be, let's use H, Ketinggian image ialah dari dasar dia, from the base to the image. Ini ialah ketinggian image. Right? Bukan. No. No. Okay, this is the base. Okay. So now, of course, kita akan guna which formula we're going to use? Kedalaman lah. Kedalaman nyata, kedalaman ketara, isn't it? Real depth, apparent depth. So N is real depth, dalam nyata bahagi dalam ketara. Okay, fine. What is the real depth? Apakah? So ini 1.25, 1.25. Okay. We want to find H. Kita nak cari H. Apakah dalam sebenar dia? What is the real depth? 5. 5. Because kedalaman kita ukur dari mana? Depth you measure from where? Depth you measure from where? Okay, good. Depth we measure from surface. Kedalaman kita ukur dari permukaan, bukan dari dasar. Ketinggian kita ukur dari dasar. Height you measure from the bottom, from the depth, from the bottom lah. But depth we always measure from the surface, dari permukaan. So kedalaman dia, the depth of the real depth, the object from the surface 5 cm kan? So we use 5. By the way, you can use cm because ini ialah nisbah, is a ratio, it doesn't matter. Tak payah guna unit SI, asalkan unit sama lah, but must be the same unit. Okay, if cm, kalau meter, okay, millimeter, it doesn't matter. Okay, the question is, what is the apparent depth? Apakah dalam ketara? What is the, yes, very good. What is the apparent depth? What is the apparent depth? Dalam ketara adalah dari permukaan, from the surface to here, isn't it? Faham tak? Understand or not? Okay. So ini ialah 5 tolak H, correct or not? 5 minus H. 5 tolak ketinggian dia. Does that make sense? Ini 5 kan? This is 5, right? Tolak H, kita dapat kedalaman dia. H is the height. H ialah ketinggian dia. Understand class? Faham tak? Tak faham. Okay. See Ini ialah okay. Dalam ketara. Apparent depth is where? From the surface to the image. Dari permukaan kepada image ialah dalam ketara. So actually this is dalam ketara. Correct or not? Because from the surface to the image lah. Real depth dalam nyata ialah dari permukaan kepada objek. Surface to the object. This is real depth. Understand? Faham tak? Ini dalam nyata kepada objek. Dalam ketara, apparent depth will be under the image. Can? Okay. So real depth is 5. What is the apparent depth here? Kita tak tahu. Right? But this apparent depth is panjang ini, the whole length here is 5, right? 5, betul tak? 5 tolak H lah. 5 minus H. Correct or not? Right? So actually you can do double work also. Boleh cari D dulu. You can find the depth first. Lepas tu ketinggian mesti 5 tolak lah. 5 minus to get the height. Because the question wants the height. Soalan nak ketinggian, bukan kedalaman. Understand or not? So di sini kalau kita terus ganti dalam sebutan ketinggian, if you straight away substitute in terms of the height, then you can get the answer lah. Alright. So here dalam ketara dia 5 minus h. And then you solve lah. You solve lah. Okay, so 5 minus h darab dengan penyebut 5 minus h darab 1.25 is this 1.25 times 5 minus h sama dengan 5. Okay, then you times lah. 1.25 darab 5 6.25 6.25 minus 1.25h ialah 5. So tolak, then you will get you plus 1.25h on both sides. Okay, never mind. I don't take shortcut. Tolak 6.25 minus 6.25 negative 1.25 isn't it? Then bahagi. Divide by negative 1.25, h ialah 1 cm. Ini ketinggian dia. This is the height of the image from the base, daripada dasar. Boleh? Kan? Okay, alright. Very good. Kan Okay. That's for your 6.1. So ini adalah pembiasan. These are all the different types of questions lah daripada pembiasan. Cikgu bagi contoh di sini. So cikgu ada soalan lagi. No, I do not encourage you to give one significant figure. Jangan bagi jawapan dalam satu satu angka bererti sahaja. Because nilai yang kita pakai di sini, the values that we use here is more than one. Some mark scheme will reject. Ada skema yang akan reject kalau awak bagi satu angka bererti saja, one significant figure, they won't accept. Cikgu pernah nampak sendiri. I've seen myself. So yeah, so cikgu tak galakkan. I don't recommend it. Walaupun ini memang adalah nilai tepat, it's an exact value. It is an exact value. But I don't recommend you ever using one. Okay? Cikgu tak galakkan lah. That's all I can say. Because dia bergantung pada skema. It depends on the mark scheme. Depends on the examiner. Yeah, can. Sebab kita ada 1.25. Because we are using 1.25, right? Yeah, a 1.0 is fine. 1.0 is fine. Give 2. At least 2 lah. Okay, bagi sekurang-kurangnya 2. Everybody okay? Okay, so this is a 6.1 class. Come, kita pergi kepada 6.2, 6.2. Total internal reflection. Pelan-pelan dalam penuh. Okay, it's a good point for a break, I think. Go to the toilet, pergi ambil air ke, pergi tandas ke. You feel about 5 minutes class. Just take a short break here. Okay class, so this is my schedule. Ini adalah jadual kelas cikgu. My Zoom class. Kalau nak join Zoom class, kita sudah mula kelas untuk Zoom untuk bulan Jun. June we have already started. So if you want to join, you can just join. No, memang takkan sempat. But I will continue lah. Saya akan teruskan. I will tell you all dalam Telegram cikgu akan bagi tahu awak bila kelas terusnya. Okay class, so this is my normal class. Ini adalah kelas cikgu, kelas Zoom. So one subject. These are the subjects. Inilah masa dia. Untuk tingkatan 4, Form 4 is 5:30 to 7. Form 5 students ialah 7.30 sampai 9. Form 5 students cikgu ada 2 kelas. One is the syllabus. Kita ikut syllabus, cikgu akan ajar syllabus. Another one is exam drill. Okay, exam drill kan. Exam drill is cikgu buat soalan percubaan yang latest trial questions. If you attended my class yesterday, kelas mathematics malam, that is how exam drill is. Cikgu akan bagi masa, give you a limited time, masa terhad untuk lengkapkan beberapa soalan, to complete a few questions. After that, we will discuss. Dan kalau soalan itu topik sudah terlalu lama, awak tak ingat, you don't remember the topic too long ago, I will also do revision on the topic. So, kita akan cover semua topik tingkatan 4 dan tingkatan 5 yang kita sudah belajar. All of the Form 4 topics and the Form 5 topics that we've learned. Okay, if you want to see which topic we did last week, awak boleh pergi tengok dalam TikTok atau Insta Cikgu. Every week I post what we learn. Itulah semua topik yang kita cover dalam satu minggu. So exam drill I highly recommend you join lah, especially now terutamanya sekarang. Okay, because your trials are near. Bagi pelajar tingkatan 5 for Form 5 students, your trials are already near. It's time to do practice ready. Dan kalau awak buat dengan bimbingan cikgu, of course lebih baik lah, is better for you. Okay, but for some reason kalau awak tak boleh join kelas cikgu pun tak apa, it's okay. You make sure you start doing yourself. Mesti buat tau. Mesti buat soalan percubaan sekarang. You don't wait anymore. Okay, tak apa. Kalau tak habis syllabus tak apa. You just do all the topics that we've already learned. Nak senang join kelas cikgu lah. If not, also do yourself. Okay. Okay, how to join? Just pergi ke mrtueltuition.com. Okay. Now class, I also want to tell you all about FlexiStudy. Okay, I think a lot of you already know about FlexiStudy. Tahu tak apa itu FlexiStudy? FlexiStudy is, ini cikgu yang mengajar. I will be the one teaching in FlexiStudy. Okay, cikgu yang ajar dalam FlexiStudy. Semua topik dia cikgu yang ajar. I'm the one who teaches everything. So you don't have to worry about quality. Okay, so you just go to mrtuition.com. Okay, pergi ke mrtuition.com. Let me show you what it is. Okay, so you go to mrtuition.com. Okay, by the way class, you can also get all the material from the untuk kelas cuti sekolah di sini on my website also gone. Okay, anyway, so got two types. Ada live class. Okay, one is live class, itu ialah kelas Zoom lah. Another one is FlexiStudy. So apa yang awak dapat dalam FlexiStudy? If you go to FlexiStudy, ada tingkatan 4 dan tingkatan 5 lah, Form 4 and Form 5. So let's say we choose Form 4 Physics. Katakan kita pilih tingkatan 4, you choose Form 4, and then you choose Physics. Okay, so let's say you click the free trial here. Okay, tekan free trial. You can straight away get the trial. Okay, do you see here? Semua topik ada. All the topics from chapter 1 until chapter 6. Semua ada. Everything is here. Let's say tiba-tiba you rasa nak bab 2 tak confident. Not confident chapter 2, you want to study chapter 2, you just click chapter 2. Semua ada. Okay. Now, contohnya, let's say you want to study chapter 3. Bab 3, tekan sini. You press the expand here. Okay, let's say you nak study, you want to study, okay, this one lah, 3.1. Okay, click here. Okay, klik sini. Now, this is what you will get. Awak akan dapat nota, macam nota yang cikgu bagi awak hari ni, just like the notes I gave you today, but it will be more complete. Sebab ini adalah nota untuk kursus intensif. My actual notes are even more, there's even more things. Cikgu sudah ringkaskan untuk kursus intensif. So, this will be the notes. Ini ialah nota dia. And then you scroll down, these are the lessons. So, each lesson maximum 1.5 jam, maximum 1.5 hours. But it could be less also. But there will be a few videos lah. Akan ada beberapa video. So, di sini contohnya ada 6 video. So, you can slowly watch lah one by one. Dan awak boleh belajar mana-mana topik. Any topic. Any topic that you want. Understand or not? This is FlexiStudy. Ini adalah FlexiStudy. So, ada tingkatan 4, there is Form 4 and there is Form 5. Okay, so what is the cost? Apakah cost dia? It is very, very cheap. Katakan you just have 1 week to study, intensive study, you want to do 1 minggu. Right? You want to learn for 1 week. Just 1 week, you want to study a certain topic. It is only RM25. RM25 untuk 1 minggu. But dalam 1 minggu itu awak boleh access semua lah. You can access all the topics. Berbaloi kan? You think about it. 7 days, awak bayar RM25. But you can access all the topics. So kalau contohnya musim peperiksaan, awak tak akan belajar macam tuition, you attend 1.5 hours. Masa peperiksaan you study 1.5 hours, isn't it? Mungkin study 3 jam, 4 jam. But awak bayar RM25. But you can study as much as you want. Sebanyak yang awak nak. You have 7 day access to everything. Faham tak? Worth it, isn't it? Berbayar. Kalau awak join tuition biasa, for example, tuition kelas cikgu, sebulan RM70. One ringgit. Right? Okay. Wait. That one cikgu. So, RM1. Okay, ada 6 jam kelas. Self class lah. If you study 7 days, you can study 6 hours. Kalau awak boleh belajar 6 jam dalam masa 7 hari, is already less than price. Betul tak? RM88. Murah kan? Right? Okay, so cikgu sudah tetapkan hal yang sangat murah. As long as rajin belajar, just 1 hour dia sudah untung. Right? Form 5 also. Kita tambah dari 5. So, this one is per subject lah. Right? So, this FlexiStudy. Kalau awak cara cikgu, like how I teach you, awak rasa sangat faham, then please go and research. Awak boleh belajar mana and in full detail dengan nota sekali. Cikgu bagi bersama dengan nota. Okay? So, this is like that. Right? Okay. I already have students that feedback kan. Memang biar berguna lah. That's why I say, kalau awak rajin belajar memang berguna lah. Right? Okay, so tadi. Okay, come, let's go back to 6.2 guys. Pada 6.2. Soalan dia sekali, yes. But bukan untuk semua. For maths and admaths memang lengkap dengan latihan lah. Maths and admaths I also give the exercise. Ada soalan. That means you don't need any extra buku latihan. Tak payah untuk maths dan admaths. For contohnya macam physics, tadi cikgu bagi soalan kan. I gave you all questions just now, right? Ini crash course ini cikgu tak bagi apa dia? What happened to the Okay, crash course cikgu tak bagi latihan. I only gave you the contoh. Right? Because tak cukup masa. Because this is crash course lah. Memang kita nak laju. But in my notes, dalam nota cikgu ada latihan juga. There are other exercises. That means ada soalan lagi. There are other questions also. Bukan satu saja. Understand or not? Soalan yang ada perhitungan semua memang cikgu ada bagilah. Okay? Right? Okay, come. Let's continue. Okay, kita masuk 6.2. 6.2. Total internal reflection. Pantulan dalam penuh. Macam mana nak study Bayu? Okay, wait. Later. Later ask me again. Lepas kelas. Okay. Alright. Total internal reflection. Pantulan dalam penuh. So, what is this total internal reflection? So, tengok sini dulu. Look at the diagram first. Tengok rajah yang pertama. So, the incident angle. Tengok sudut tuju dia. So, ini cahaya merambat dari, can you see, the light is moving from glass, dari kaca ke udara. Okay. Ini sangat penting. This is very important. Very, very important. Kenapa ini penting? Because dia merambat ke medium yang lain. When it is propagating to different medium here, look at where it is moving. Tengok dia bergerak ke mana. Right? Look at where it's moving. Dia bergerak menjauhi normal. Away from the normal, right? Because dia bergerak dari objek dengan ketepatan optik lebih tinggi ke rendah. Higher optical density to low optical density. Isn't it? That's why dia menjadi lebih laju. It becomes faster and it moves away from the normal. Jadi dia membengkok menjauhi normal. Okay? Kan? Okay. So this is very important. Alright. So sudut tuju, apabila sudut tuju macam ni, less than C. Okay. So first we have to discuss apakah itu C. What is C? Right? Look at this. Sudut tuju ini, this incident angle is C. Adalah C. C ini bukan laju cahaya dalam vacuum. This is a different C. It is not the speed of light in vacuum. Don't get confused, class. Jangan keliru, Okay. C here is not speed. C mewakili sudut. This C represents an angle. Okay, what angle is that? Okay. C adalah sudut tuju, is the incident angle. When the refracted angle, bila sudut pembiasan, ialah 90 darjah. Yes, that's right. C is the angle when the angle of refraction, the incident angle, sudut tuju, apabila sudut pembiasan, when the refracted angle is 90 degrees. That is the definition. Do you understand? So let's define this first. Kita takrifkan yang ini dulu. So it's critical angle, sudut genting. C ialah sudut genting. Okay, critical angle is the angle of incidence okay, sudut tuju dalam medium dengan ketepatan optik tinggi. In the medium with the higher optical density. For example, glass to water glass lah. Mesti dalam medium dengan ketepatan optik tinggi. Okay, later you are going to tell me why. Awak akan terangkan kenapa. Apabila sudut biasan dalam medium dengan ketepatan optik lebih rendah, the lower optical density medium, incident angle, that is the okay, so when the refracted angle of refraction in the medium with the lower optical density is 90 degrees. One of you become software engineer, design a better software for me, Okay, angle of incidence in the medium with the high optical density. Okay, dalam medium dengan ketepatan optik yang tinggi, apabila sudut biasan when the angle of refraction is 90 degrees in the lower density, lower optical density, medium with the lower optical density, medium dengan ketepatan optik yang lebih rendah. It's a lot of words, but daripada rajah tadi awak boleh faham kan? From the diagram just now you can understand, isn't it? Okay, look at the diagram again. So again, can you see the angle of refraction here? Nampak tak sudut biasan di sini 90 darjah, 90 degrees, right? So when the angle of refraction in air is 90 degrees because air is lower optical density, ketepatan optik yang lebih rendah. Bila sudut ini ialah 90 darjah, then this incident angle, sudut tujuh ini ialah sudut genting. This is the critical angle. Sudut tujuh ini ialah sudut genting. Understand? Okay, how does this happen? Right? Macam mana ini berlaku? So first, we start with apabila sudut tujuh kurang daripada sudut genting. When the incident angle is less than the critical angle, what will happen? The light ray is refracted away from normal. Right? Sinar cahaya dibiaskan menjauhi normal. Why? Because dari kaca ke udara, ketepatan optik tinggi ke rendah, high to low optical density, so it moves away from normal. Okay? However, some of the light, okay, ada sebahagian daripada cahaya yang akan dipantulkan balik. Some of it will be reflected back. A small amount. Kebanyakan dia akan dibiaskan, ada yang akan dipantulkan balik. Alright? So where is it reflected? Mana dia dibiaskan? Di sini, at the boundary, pada sempadan. Pada sempadan ini, dia akan dibiaskan. Dan dipantulkan. It will be refracted and it will be reflected as well. Some lah, some. Okay, when we increase this incident angle, bila kita tinggikan sudut 7 ini, okay, increase the incident angle, what will happen? Dia akan membengkok lebih lah, it will bend more, isn't it? Right, dia akan lebih menjauhi normal. It will be further and further away from the normal. Semakin jauh daripada normal, betul tak? Right? Sampai until, so you can see this ray, sudut yang dibiaskan ini, the refracted ray, will become closer and closer to the boundary. Dia akan semakin dekat dengan sempadan, betul tak? So there will come an angle, akan sampai satu sudut di mana memang dia dibiaskan pada sempadan. It will be refracted at the boundary. Understand or not? Pada masa inilah, it is during this time that the incident angle is the critical angle. Pada masa inilah, sudut 7 adalah sudut genting. When it is refracted along the boundary, sepanjang sempadan. Okay, so more of the light is reflected. Lebih banyak cahaya dipantulkan. Bukan semua, not all, but more is reflected. Okay, berbanding dengan sebelumnya lah, before, compared to before. Kan? So here we start here. Kita mula di sini. Okay. So this time, this angle is less than the critical angle. Kurang daripada sudut genting. Right? Sudut 7. This incident angle. Now, when you slowly increase the incident angle, that means when we bend the ray of light from here, kalau kita meningkatkan sudut 7, okay, increase the incident angle, it will bend more, isn't it? Dia akan membengkok dengan lebih lah selepas dibiaskan. After refracted, it will bend more. Right? So you increase again, it will bend more. Increase again, dia akan membengkok lagi. Sampailah dia akan sampai satu ketika, reach a time where, okay, this angle, at this angle, pada satu sudut 7, at a particular incident angle, the angle of refraction sudut biasan ialah 90 darjah. So it will bend until finally it is at the boundary. Dia berada pada sempadan. Sempadan antara dua medium. The boundary between the two mediums. Faham tak? Understand or not? Okay. So at this time, apabila sudut biasan dia 90 darjah, when the refracted angle is 90 degrees, sudut 7 ini, this incident angle is the angle, the critical angle. Inilah C. Sudut 7 dia. Sudut 7 ini ialah sudut genting. Faham tak? The I is the C. When? Apabila sudut biasan 90 darjah. Understand? Faham? Okay. Which one is the critical angle? Yang mana satu sudut genting? No light that comes out of the medium, yes. No light comes out of the medium. Which is the critical angle, class? Yang mana satu adalah sudut genting? TQRSTU. Which one? Hmm. 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 Good. 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 Think class. Think. Mana satu sudut genting? Which is critical angle? Okay. Okay. Very good. What is critical angle again? Sudut genting ialah sudut tuju. It must be the incident angle. That means before the refraction. Sebelum pembiasan lah. So is either sama ada P, R atau T. It must be the incident angle. Betul tak? Right? Yes. Very good. Salah satu daripada sini lah. Okay. Sudut tuju. Apabila what? Apabila sudut biasan when the angle of refraction is 90 darjah. When the angle of refraction is 90 degrees. Mana sudut pembiasan 90 darjah? Sini kan? U, isn't it? Right? That means T lah. T is C. Faham tak? T is the critical angle. Boleh? Understand now? Faham? Okay? Right. So, akan ada lebih banyak cahaya yang dipantulkan juga. There will be more light that is reflected as well. Right? But, jika sudut tuju ini lebih daripada sudut genting, let's say this angle is 42 lah, 42. Okay? Kalau sudut ini contohnya 43. If the angle of incidence now is more than the critical angle, lebih daripada sudut genting 42, 43, what will happen? Dia tak boleh dibiaskan lagi. It cannot be refracted anymore, isn't it? Sebab ini pada sudut genting at the critical angle is already at the boundary. Dia sudah di sempadan. Mana dia nak membengkok lagi, betul tak? Where is it going to bend some more? Right? So, when the angle of incidence is more than the critical angle, lebih daripada sudut genting, what will happen? Semua akan dipantulkan balik. Everything will be reflected. Dipantulkan. Bukan lagi dibiaskan. Everything will be reflected. And this is what we call, yes, total internal reflection. Pantulan dalam penuh. Now you know why it's called pantulan dalam. Right? Internal reflection because it is reflected back into the same medium. Dipantulkan balik kepada medium yang sama. Dari kaca dia dipantulkan balik ke dalam kaca. From glass it is reflected back into glass. Pantulan dalam lah. Why penuh? Because sebelum ini memang ada pantulan juga. We also have some reflection. Even when the incident angle is less than the critical angle or equals to critical angle. Walaupun sudut tuju sama dengan atau kurang daripada sudut genting, ada pantulan juga, tapi sikit lah. But apabila sudut tuju lebih daripada sudut genting, when the incident angle is greater than the critical angle, we have total internal reflection. Pantulan dalam penuh. Everything is reflected back, bukan sebahagian saja. Faham kelas? Understand or not? Okay? Alright. So, now we can define total internal reflection. Sekarang kita boleh takrifkan dia. So, total internal reflection is a reflection. Is a reflection. Dia bukan pembiasan, dia pantulan cahaya. Reflection of light. Okay, yang merambat dari, it has to travel from where to where? When we talk about optical density, ketepatan optik, tinggi ke rendah atau rendah ke tinggi? High to low or low to high, optical density? Think, class, think. Tinggi ke rendah atau rendah ke tinggi? Look at our diagram. Tengok raja kita. Right? Where is it? High to low or low to high? Dalam contoh kita, dia merambat dari kaca ke udara, betul tak? Right? From glass to air, that is? Okay, yes, okay. Kaca lebih tinggi, betul tak? Glass is higher, isn't it? So, it must be from high to low. Okay, now the question is why? Awak bagi tahu cikgu kenapa? Why must it be from high to low? Kenapa tak boleh daripada rendah ke tinggi? Or can lah? Is it possible from low to high? What do you think? Boleh tak? Can. Low to high. Also can. Very good. Very good. Tak boleh. Because why? Because Kalau rendah ke tinggi, low to high, let's say dia merambat dari, okay, let's say it is propagating from air to glass. Udara kepada kaca. Okay, udara kepada kaca. Let's say it's going from air to glass. Kalau dia merambat dari udara ke kaca, okay, it is going to slow down. Dia akan laju, dia akan berkurang apabila masuk kaca. Where will it be refracted? Dia akan dibiaskan mana? Kan? Where will it be refracted? Dia akan dibiaskan ke arah normal, betul tak? Towards the normal one. Correct or not? Kan? Understand or not? So, bila kita, if you increase, okay, sudut ini, you increase your I, okay, R akan bertambah. But it's always here. Understand? Dia tidak akan mendekati sempadan. It will never go towards the boundary because it's refracted away from normal. Because it's refracted towards the normal. Sebab dia dibiaskan ke arah normal, dia memang takkan sampai ke sempadan. Understand or not? Pantulan dalam penuh tak boleh berlaku. Yes. Okay? Boleh? Alright? So for total internal reflection to occur, it must always go towards the boundary. Dia mesti ke arah sempadan. Baru dia boleh dipantulkan sepenuhnya. Okay? Okay, so what is total internal reflection? Total internal reflection, pantulan dalam penuh ialah bila sudut, so this one cannot lah. Pantulan dalam penuh tak boleh berlaku. So total internal reflection is when the incident angle, bila sudut tuju, okay, bila sudut tuju ini lebih daripada sudut genting. When the incident angle is more than the critical angle, this incident angle, more than the critical angle, lebih daripada sudut tuju, lebih daripada sudut genting, dan also it is moving from medium with higher optical density, ketepatan optik lebih tinggi, ke rendah. Right? So then what will happen? Semua cahaya tidak akan dibiaskan lagi. It will not be refracted anymore. There's no more refraction here. Tak ada pembiasan lagi. Semua cahaya akan, yes, betul, mesti mendekati normal. All the light will be reflected back into the medium with higher optical density. Semua cahaya akan dipantulkan balik ke dalam medium dengan ketepatan optik yang lebih tinggi. So this I is equals to R. Di sini kita ikut hukum untuk pantulan. We follow the laws for reflection. I equals to R already. Understand? Faham? Are we clear, class? Jelas? Okay. Macam mana soalan dia? Di sini soalan dia. Okay, very good. Soalan di sini semua aplikasi. Semua aplikasi. Okay. Come. Okay, so let's continue first. Pantulan cahaya. Okay. So it has to be moving from medium with higher optical density to lower optical density. Okay, higher to lower. Supaya dia boleh menjauhi normal. So that it can move away from normal. So that it can move in the direction back inside the same medium. Supaya dia boleh bergerak ke arah yang dia boleh masuk balik medium yang sama lah. Pantulan dalam penuh kan? Total internal reflection. So where is the light reflected? Di mana dia dipantulkan? It is reflected at the boundary. At the boundary between the two mediums. Dia dipantulkan pada sempadan kedua-dua medium. Okay. Now we do have some calculation here. Calculation is very easy. Perhitungan di sini sangat senang. Okay, sudah. Okay, calculation in this question is in this topic is very easy lah. So perhitungan dia, we go back to Okay, so the formula here ialah we are actually going to use sin I per sin R. Okay, cikgu ajar terus di sini. I'm going to teach you directly here how we get the formula for critical angle. Macam mana kita dapat rumus yang menggunakan sudut sudut genting. Okay, so refractive index of water, indeks biasan air ialah 1.33. Refractive index of water is 1.33. So N is 1.33. N untuk air 1.33. Hitung sudut genting. Calculate the critical angle. Okay, you see So, what is the critical angle? So, kalau ini air, this is water and this is air. Udara Okay, air dan udara. So, untuk pantulan sudut genting dia ialah critical angle will be when the water comes from, when the ray comes from water, apabila sinar datang dari air dengan ketepatan optik lebih tinggi higher optical density here. This will be C. Ini ialah C kalau dia dibiaskan sepanjang sepadan. If it's refracted along the boundary, isn't it? Correct or not? So that means sudut biasan, this is 90 degrees lah. This is the critical angle, right? Ini sudut genting kan? And bila kita ada indeks pembiasan, we can use N is sin I per sin R. Right? Because di sini kita ada udara. We have air, right? Okay, we have air, right? So how? Yes, very good. So di sini kita ganti apa sudut di udara. The angle in the air, again the direction doesn't matter, Tak kisah apa arah dia, remember? Okay, daripada 6.1 from 6.1, it actually doesn't matter. Sebab bila cahaya merambat arah bertentangan, when the light is moving the opposite direction, it will follow the same path. Dia akan guna lintasan yang sama juga. Okay, so I will be air. So sin 90 lah, sin of 90 bahagi over sin. So kalau ini 7, R will be C lah. Do you understand, class? Faham tak? Okay, this is from 6.1 just now. Okay, class. What is sin 90? Cuba guna calculator. Apakah itu sin 90? Sin 90 is 1. Very good. So, rumus dia boleh diringkaskan kepada, can be simplified to 1 over sin C. Inilah rumus untuk sudut genting. This is the formula for critical angle. N is 1 over sin C. Kan? So, we have one more formula for refractive index. Satu lagi rumus untuk indeks pembiasan di sini. 6.1 kita belajar 4. This is the fifth one. Boleh? Okay. So, now we can find lah. 1.33, 1.33 is 1 over sin C. Sudut genting dia. So, sin C will be, sin C ialah 1 per 1 over 1.33 lah. Okay. Times sin C bahagi 1.33. And then what will be C? Inverse sin. Sin songsang. Okay. This one you already learned in your form 2. Form 1 or form 2? Inverse sin. You know. Yeah. So, jawapan dia ialah 48.75 degrees. 48.75 darjah. Right? Those of you who plan to get FlexiStudy, nanti dalam nota itu cikgu ada lebih banyak soalan. I have more questions here. You all can try some more. Okay? Okay. Can? So, this is the calculation. Ini saja perhitungan dia. We only have one formula here. Very easy. Apa yang selalu keluar daripada bab ini ialah what always comes out in this chapter is actually the application, the phenomena and the application. Okay, fenomena dengan aplikasi dia. Okay, so the phenomena. Fenomena yang melibatkan pantulan dalam penuh. Total internal reflection. Alright, so the first one is formation of rainbow, pembentukan pelangi. Okay, so what happens when the light ray enters water droplets? Ini adalah titisan air. Apa yang berlaku apabila sinar cahaya masuk titisan air. So again, different optical density, isn't it? Right? Ketupatan optik tak sama. So you draw your normal here, lukis normal di sini. What will happen? Dia akan dibiaskan ke mana? Where will it be refracted? Towards or away? Dia laju ke perlahan bila dia masuk air. When it goes into the water, it will become slower, isn't it? Perlahan lah, kan? Very good. So, jadi dia akan dibiaskan be refracted back. Towards the normal. Very good. Ke arah normal. So, okay. But, tetapi, cahaya putih, white light, has all the colours, right? Dia terdiri daripada semua warna, kan? All the colours. Jadi, semua warna ini, setiap warna ini dia ada panjang gelombang tertentu lah. It has a specific wavelength. Each color has a specific wavelength. Jadi dia akan dibiaskan pada darjah yang berlainan. It will be refracted in different degrees. Okay. So you must remember cahaya merah, red light is refracted the least. Paling kurang dibiaskan. Okay. Sebab panjang gelombang dia panjang. It's a long wavelength. So it is refracted the least. Apa yang akan dibiaskan paling banyak? Refracted the most will be blue, biru. Ultra actually is violet lah, ungu violet. The other end, okay, violet will be reflected more. Ini akan dipantulkan dengan lebih. Violet, ungu Okay, so when sunlight enters raindrops, two things happen. Okay, nombor satu ialah refraction, pembiasan. So in my notes, ini kelas intensif. This is intensive class. In my actual notes, sini kosong. You have to write everything from scratch. Kenapa cikgu buat macam tu? Why do I do it like that? It will help you remember. Bila awak tulis, awak akan ingat dengan lebih baik. It will help you remember. Alright? That's why cikgu biarkan dia kosong. But now, because it's a crash course, we want to be fast. So cikgu I give you fill in the blanks instead. So di sini pembiasan akan berlaku. So when you have the time, you should actually try to write everything again. Dia macam awak jawab soalan lah. It's like as if you're answering question in the exam. Soalan essay. When you write everything, isn't it? Okay. So refraction occurs and then white light will also undergo apa phenomena dia? Do you remember the phenomenon? This is your lower secondary. Mendengar rendah. Cahaya putih akan mengalami what's it called? Okay, never mind. Dispersion class. Penyebaran. Ingat tak? Remember your dispersion? Okay, it will be dispersed into different colors. Remember the prism or not? Ingat tak? Prisma. Okay, so dispersion into the different colors lah, the 7 colors, 7 warna yang berlainan. Right? All the colors will be separated, diasingkan. Okay, alright. Never mind, don't worry. So you remember the prism, bila dia masuk prisma, when white light enters the prism, cahaya putih bila dia masuk ke dalam prisma, it will be spread out. Right? Dia akan keluar semua warna pelangi, all the colors of the rainbow, isn't it? This is dispersion lah. Ini ialah penyebaran cahaya. From white light, we get the 7 colors. Daripada cahaya putih, kita dapat 7 warna. Okay? Alright. So, at all the different colors, semua warna yang berbeza mengalami apa? They will experience. So, now we are reaching here. Sini semua warna yang berbeza, bila dia sampai ke sini, when they reach this side, okay, they will all experience, semua akan mengalami pantulan dalam penuh. Total internal reflection. Yes. Okay, semua akan dipantulkan balik. Everything will be reflected back. Because bila dia sampai sini, sudut tuju dia lebih daripada sudut genting lah. The incident angle will become more than the critical angle here. So it will be reflected. Right, so this is your violet. Ini ialah ungu Okay, but then this one your red, follow the rules of reflection sama dengan sudut 7. Red will come down. Nampak tak dia sudah tukar tempat? Can you see it swap places? Asalnya merah di atas, originally red is up, but when it undergoes your total internal reflection, pantulan dalam penuh, red will be down, merah di bawah. Can? Okay, so this is the next thing lah. Semua warna yang berlainan akan mengalami, everything will experience total internal reflection. Pantulan dalam penuh. Okay, then once again dia akan sampai ke sempadan antara air dan udara. Once again it reaches the boundary between air and water, isn't it? Here, sini. What is going to happen here? Apa yang berlaku di sini? So here it is going to be, di sini dia akan dibiaskan lagi. Refraction will happen again. Okay, apabila cahaya nak keluar daripada titisan air, when it wants to leave the water droplet, another refraction will occur. Kali ini dari air ke udara. Where is it going to be bent? Dia membengkok ke mana, kelas? Menjauhi ke, mendekati normal, away or towards normal? Water to air. Air ke udara. Dia semakin laju ke perlahan? Is it faster or slower? Very good. Very good. Faster, lebih laju maksudnya. That means jauhi normal. Very good. Away from the normal. So sepatutnya sini, so you draw lah away from the normal. Menjauhi normal. So here. Okay. This one also menjauhi normal. So here. Okay. Kan? So again, you must say dia mengalami pembiasan lah, refraction as it leaves. Okay, so here it undergoes refraction. Actually, it goes dispersion again as well. Refraction and dispersion. Refraction and dispersion. Again, as it leaves the droplet. So what does the observer see? Observer see rainbow. Pemerhati akan melihat pelangi. Kan? So formation of rainbow, you must remember pembentukan pelangi ini di bawah pantulan dalam penuh. Is under total internal reflection. Ini dia jarang tanya tau. They rarely ask this. So there's a chance it will come out. Okay, there's a chance it will come out. Fenomena yang dia selalu tanya, the phenomenon that they always ask is actually the next one. Mirage. Tahu tak apa itu logam maya? Okay class, you know when it's a very hot day, pada hari yang sangat panas, waktu tengah hari, afternoon, these few days sangat panas kan? You all mesti ada cuti kan? You all go out. So bila awak berada di atas jalan raya, when you're on the road, in the car, dalam kereta, right? Bila awak melihat ke arah jalan raya, when you look in the direction of the road, okay, di depan, in front, nampak macam ada air. Looks like there's a puddle of water. Okay, nampak macam ada air yang bertakung di atas jalan raya. Satu lopak air lah. But bila kereta lalu bahagian itu, when the car passes by that place, there's no water. Pernah tak? Have you all experienced this before? Pernah ke tak? Try to think back. When you are in a car, mesti hari yang panas. It must be a hot day. Hari yang panas. That means waktu tengah hari, afternoon. Right? Then you look in front, ada lopak air. Right? Okay. Then when you pass by, tak ada. Why? Okay. Pernah. Okay, good. Tak pernah means dalam kereta tengok phone lah. Isn't it? Okay. Tengok luar sekali-sekala. Right? So, why? It's an illusion. Okay. Kenapa ini berlaku? Okay. So, on a hot day, the ground becomes very hot lah, of course. Dia menjadi sangat panas. This is the key. Okay. Tanah menjadi sangat panas. So when the ground becomes excuse me, when the ground becomes very hot, what happen is the heat from the ground, haba daripada tanah ini akan diradiasikan. The heat from the ground is radiated to the air above the ground, kepada udara di atas tanah. Okay. So the ground absorbs the heat, tanah akan serap haba. Now, don't forget, tanah ini, the ground will have a high specific heat capacity here lah. Okay, so dia akan simpan banyak tenaga haba to keep a lot of heat compared to the air, berbanding dengan udara, and then the heat will be radiated back up. Daripada tanah ini, dia akan diradiasikan ke udara di atas dia. Okay, so what does this do? Apa yang berlaku di sini? Heat is radiated here. Jadi, that means the layer of air just above the ground, lapisan udara di atas tanah, adalah panas. The temperature here is high. Okay. Then lapisan udara yang seterusnya, lapisan-lapisan udara yang seterusnya, the following layers of air, it will be less and less hot lah. Semakin sejuk. Be cooler and cooler, isn't it? Right? Correct or not? Faham tak? It'll be cooler and cooler. So when we have different layers of air with different temperature, bila kita ada lapisan udara yang berlainan dengan suhu yang berlainan. Okay, wait. Let's fill in the blank first. So the layer nearest the ground will be, of course, the hottest lah, paling panas kan. And then the layer furthest from the ground, paling jauh daripada tanah, paling sejuk. Okay, hottest and the coolest, the coldest. Okay. Now can you tell me, when we have layers of air with different temperature, dia mempengaruhi apa sebenarnya? What does it affect? Selain suhu yang berlainan, jadi apa yang akan berubah juga? Ketumpatan. Very good. The density of the air. Ketumpatan udara akan berubah. Very good. So kalau panas, ketumpatan dia rendah ke tinggi? If it's hot, the density is low or high? Kalau panas, very good. Kalau panas, if it's hot, what will happen to the air? Objek yang panas akan, any object that is hot will what happens to hot objects? Dia akan less dense. Why is it less dense? Because when the object is hot, it will expand. Dia akan mengembang. Betul tak? Bila objek dipanaskan, dia mengembang kan? When objects are heated, they expand, isn't it? Same like air lah. Kalau udara dipanaskan, kalau udara dia suhu dia lebih tinggi, if the temperature is higher, it will expand more. Dia akan mengembang dengan lebih. Bila dia mengembang, when it expands, what happen to density? Apa yang berlaku kepada ketumpatan? Apa yang berlaku kepada Gcm per unit isi padu? What happens to the mass per unit volume? It will drop, right? Turun lah. Betul tak? Because it's expanding. Sebab dia mengembang. Right? So it's spread out. Jadi, ketumpatan berkurang. So you have to remember, high temperature, low density. ketupatan optik rendah. Optical density will follow as well lah. Ketupatan bila sejuk, ketupatan tinggi. Cold means high density. Because bila dia sejuk, dia akan mengecut. When it's cold, it will contract. So density increase. Ketupatan dia naik. Understand? Faham? Okay, so now walaupun semuanya udara, even though everything is air, each layer has a different optical density disebabkan oleh suhu yang berlainan. Faham tak? Okay, setiap lapisan ada ketupatan optik yang berlainan. And now what will happen? Refraction. Sekarang pembiasan akan berlaku. So, where does the light come from? The light comes from the cloud. Daripada awan. What is a cloud? Basically a pool of water. Right? Awan itu adalah air lah. Okay? So, the light ray comes from the cloud. Okay, dia datang dari awan. Now, what will happen when it goes from this layer, lapisan ini yang lebih sejuk, ke lapisan yang lebih panas? So the optical density here is higher, optical density here is lower. Apa yang berlaku pada laju dia? What happens to the speed when it goes to a lower layer with a higher temperature and a lower optical density? Bila dia turun ke lapisan yang lebih rendah dengan lapisan bawah dengan suhu yang tinggi dan ketupatan rendah. Faster, very good. Laju. So where will it bend? Where will it bend? Kalau dia semakin laju, away. Very good. Away from normal. So, sinilah. Okay, it bends here. Away from normal. Okay. So, at this layer, what will happen? Sekali lagi, bila dia turun, when it's going down, dia pergi dari ketupatan optik yang rendah, yang rendah kepada yang lebih rendah, tinggi ke rendah lah, high to low. High to low. What happened again? Lebih laju lagi, away from normal again. Yes, away from normal again. Okay, menjauhi normal sekali lagi. Can you see, nampak tak apa yang berlaku kepada sudut tuju dia? Can you see what's happening to the incident angle? See not? Sudut tuju dia semakin besar. Incident angle is increasing. Sudut tuju dia semakin besar. Right. So, there will come a point where akan tiba satu ketika di mana sudut tuju lebih daripada sudut genting. When the incident angle is more than the critical angle. Dia akan semakin besar sampai lebih daripada sudut genting, and then what will happen? Bila sudut tuju lebih daripada sudut genting, when the incident angle finally becomes greater than the critical angle, what will happen? Apa fenomena yang berlaku di sini? Yes, pantulan dalam penuh. Total internal reflection occurs. Okay, total internal reflection occurs. Okay, now bila dia naik, when it goes up, okay, so now it's going from lower optical density to higher optical density. Bila dia naik, when it's going up, because colder, isn't it? Lebih sejuk kan? So, dari ketupatan rendah ke tinggi, dia menjadi semakin perlahan, slower, and it will be refracted towards the normal, ke arah normal. So, ini akan berterusan sampai ke mata lah, until it reaches the eyes. Until it reaches the eyes. That is the story. So basically class is very fascinating, isn't it? Right? Sangat menarik kan? Bila awak nampak ada satu lopak air dalam jalan raya, when you see there's on a hot day, pada hari yang panas, when you see there's a puddle of water on the road, you are actually looking at the cloud. Awak sedang nampak awan. Fascinating, isn't it? Okay, this is the same concept for, tahu tak bila in movies dalam filem kan, dalam filem there's always in the desert, kalau dalam apa dia, gurun kan, you know, they always see an oasis that doesn't exist Kan? Dia akan nampak macam ada satu tempat yang ada banyak air, right? Oasis. Tapi bila dia dia berjalan ke arah kawasan yang ada air itu, then when they reach there, there's nothing. Right? This one can boleh, right? So that is the same concept. It's because of total internal reflection. Sebenarnya dia nampak awan. They're actually looking at clouds somewhere very far away. Okay, let's complete this. So light from the cloud is gradually first dari sini from here, from the cloud is gradually refracted. Dia akan dibiaskan arah mana? It will be refracted away from the normal lah. Menjauhi normal dulu sebab dia semakin laju, semakin faster and faster. So away from the normal. As it travels from upper layers to lower layers, lapisan atas ke bawah ini, away from the normal, menjauhi normal. Dibiaskan secara beransur-ansur. Menjauhi normal. Okay, then what will happen apabila finally when I is more than C, apa yang berlaku? This one you know already lah. Pantulan dalam penuh, total internal reflection will occur. Finally, total internal reflection will occur. And then now dia akan bergerak ke arah atas pula. Now it's going to move upwards towards the upper layers. Dari lapisan ke bawah ke lapisan atas kan? So then what will happen? Pada ketika ini, dia akan, it will be refracted again, but this time ke arah normal, towards the normal, isn't it? Because it's going to higher optical density. Ketepatan optik lebih tinggi apabila dia naik towards the normal. Okay. So, pemerhati akan nampak, you always end with the what the observer sees. Pemerhati akan nampak apa? Dia akan nampak image awan. The observer will see the image of a cloud on as a puddle on the road. Sebagai lopak air di atas jalan raya. Okay, can? Faham? Very fascinating. Very fascinating. Okay, so these are the two phenomena. There's two phenomena. Ini adalah dua fenomena yang berkaitan dengan pantaran dalam penuh. Now the next is application. Seterusnya ialah aplikasi. Application is very important. Application is very important. Terutamanya ini. This one sudah keluar banyak kali. It's come out many times already in the trials. Dalam percubaan. Optical fiber, gentian optik. Very popular dalam bahagian B, bahagian C. Section B, section C is very popular. Okay. So take note of this lah. Especially bagi tingkatan 4, those of you in Form 4, your finals, very likely this will come out. Okay, very likely this will come out. Okay, class, we've already another 5 minutes. So I think kita berhenti di sini dulu. I will continue this, don't worry. Kelas ini takkan berakhir di sini. I will tell you all again. Cikgu, awak tengoklah dalam Telegram nanti. You wait for the announcement. Bila cikgu senang, when I'm free again, which will be within the coming few weeks lah. Most likely Saturday. Cikgu akan bagi tahu awak bila kelas terusnya. Then you all will continue this. Kita akan teruskan sampai kita habiskan dia. Okay? Alright. Okay kelas, so those of you who want to join my class, just go to mrwelltuition.com. Boleh join dari sana. Right now, Form 4, we are doing, cikgu buat bab, I'm finishing off chapter 3. Kita sudah nak masuk bab 4. We are going to chapter 4 adalah 4.2. Okay, Form 5 sekarang kita dekat electric dan electricity. Right, so if you want to join. Those of you Form 5, if you get time, join the exam drill. Okay. Again, don't forget about FlexiStudy. Siapa yang nak belajar short term, or even if you want to take it as your normal tuition, you can go and join FlexiStudy. Okay, just go and get access. Terpulang pada awak. Alright guys, I see you all in the next class. Jumpa dalam kelas terusnya. Any questions you can stay back.